Okay, what we have here is a graph of a quadratic. Right now it is set to have an equation of x squared plus 4x minus 5. Its vertex, although you can't really see it, is at 2, negative 9, and we can tell that from the vertex form here. We take the negative of what's in the parentheses, and then we take this, and that gives us the x and y coordinates of our vertex. Notice as well that it crosses the x-axis at negative 5, 0, and 1, 0. These are our roots. Negative 5 and 1 are also the two values of x that will set this equation equal to 0. In other words, when we plug in negative 5 here, we'll get out a value of 0. When we plug in 1, we'll also get out a value of 0. We can tell that from the graph because at these points right here, the y value, which is the value of the function, is at 0. And that occurs when x is equal to negative 5 or when x is equal to 1. Notice we also have our quadratic formula here, which again is composed of negative b over 2a, which gives us the value of the x value of our vertex as well as the x value of our axis of symmetry, or negative 2. This over here gives us what we have to add or subtract from the axis of symmetry to get to our two roots. So what this is saying to us is that we have to add 3 or subtract 3 from negative 2 in order to get to our roots. So we have 2 plus 3 gives us positive 1. That's root number 1 here. And we have negative 2 minus 3 gives us negative 5. That's our other root here. Okay, notice what happens as I start to change the value of c. As this vertex starts to slide up toward the x-axis. So you'll notice a couple things. First of all, the equation changed, and we now have x squared plus 4x, the vertex value, x plus 2 squared minus 4, because our vertex is now at negative 2, negative 4. Notice over here as well that instead of having negative 2 plus or minus 3, we now have negative 2 plus or minus 2, because this value here, b squared minus 4ac over 2a, now has a value equal to 2. The discriminant, which is this value b squared minus 4ac that's under the square root sign, is equal to 16. And that's shown right here. So we have b squared, or 4 squared, minus 4 times 1 times c, or 16 minus 0 gives us 16. As we keep changing c, the value of our discriminant changes. Now notice what happens to the roots as we get closer and closer to the x-axis. They are getting closer and closer to each other, and that's because this discriminant is getting smaller and smaller, because b and a are staying the same, but c is getting larger, which means that we're subtracting a larger amount here, which means that the value under the radical is getting smaller. So now we have negative 2 plus or minus 1. So now the roots, instead of being 6 apart or 4 units apart as they were earlier, are now just 2 units apart. Well, the natural next step is that as they move closer and closer, they get so close together that they merge. And they become just one root. And that happens when the root is equal to the vertex and is positioned exactly on the x-axis. So right here, we have the one place where this quadratic intersects the x-axis, and that's here at negative 2, 0. That gives us just one root. It means there's only one value of x that makes this quadratic take a value of 0 when we plug it in. If we plug in x is equal to negative 2, this will turn to 0. Negative 2 squared is 4, plus 4 times negative 2 is negative 8. So we have 4 minus 8 is negative 4, plus 4 is 0. So f of x is equal to 0 when x is equal to negative 2. The other thing you notice is that our vertex form has now become a perfect square trinomial. In other words, the y value that we were adding or subtracting as the y value of the vertex is now equal to 0. So we're left with just this value x plus or minus some quantity squared. Again, this quantity, we're subtracting negative 2 here, and negative 2 is the x value of our vertex, the x value of our axis of symmetry. So take note of the fact that the discriminant is now equal to 0. So when the discriminant is positive, we have two roots, two solutions to our equation. When we move the vertex up onto the axis, the discriminant is now equal to 0, and we have only one solution to our equation that sets it equal to 0. Now notice what happens when we move above the axis. The vertex is now above the x-axis, and since the parabola opens upward, it never crosses the x-axis, which means there are no intercepts on the x-axis. That means the roots are undefined because it never crosses the x-axis. Notice as well what happened to our discriminant. It is now negative. And so when we try to take the square root of a negative number here, we can't do that. There is no real number that when squared is equal to a negative number. So in other words, there are no values of x that we can plug into this equation and make it equal to 0. And one of the ways you can tell looking at the vertex form is because x plus 2 squared, no matter what x is going to be either 0 or positive. And when we add 1 to it, it's still going to be it's always going to be positive. So we're never going to be able to get the value of this equal to anything less than 1. That's why our vertex has a y value of 1. So the discriminant gives us a very quick way of determining whether we have two solutions, one solution, or 0 solutions. When the discriminant is positive, that means that our parabola crosses the x-axis in two locations. And the roots, we get two distinct roots here. Again, one is -2, in this case +2, and the other is -2 -2. When we move the c value so that our vertex rests exactly on the x-axis, we now have only one solution to the equation f of x is equal to 0. There's only one value of x that we can plug in to make this equation equal 0, and that value is -2. And that we can tell when the discriminant is equal to 0, because this whole thing on the right of this expression becomes 0, so we just have -b over 2a, or -2 in this case, plus or minus 0. -2 plus 0 is -2. -2 minus 0 is also -2. When the discriminant is negative, that means we have no roots, no real solutions to the equation x squared plus 4x plus 6 is equal to 0. This never crosses the x-axis. So the discriminant helps us determine whether we have two solutions, one solution, or 0 solutions to the equation x squared plus 4x plus 6 is equal to 0. Or we could do it with any value of b. It doesn't matter. We just happen to choose that. So now we see that when the discriminant, when c is up to positive 9, then we have a positive discriminant, which means we have two roots. As c gets larger and larger until it gets all the way up to a value of 9, we have two roots that are getting closer and closer together until finally they merge when c is equal to 9. The discriminant is equal to 0, b squared minus 4ac. So down here, discriminant is positive. When the vertex is on the x-axis, discriminant is 0. We have one solution. When the discriminant is negative, that, in other words, that the vertex is above the x-axis for an upward opening quadratic, then we have no roots. The roots are undefined, and the discriminant is negative, and we can't take the square root of a negative number.